In this section 7.1, we're going to talk a little bit about degree measures. Everything we've done up until this point has been using degrees as our angle measure. When we measure a degree, it's going to be, a measure of, say, 5 degrees or 38.6 degrees. What we're going to do in this section is talk about, one, how to change our decimal of a degree into degrees, minutes, and seconds. Minutes and seconds is just a different way to write degrees. And then we're also going to talk about radians, which is another way to measure an angle. It's dealing with a different, different method. So we've talked a little bit about that in the calculator, about how being in degree mode and radian mode can be different. So we're going to talk a little bit about that. So let's first talk about converting our degrees into degrees, minutes, and seconds. So what we want to do is minutes and seconds work the exact same way that minutes and seconds do in an hour. So when we do this, this is how we're going to look at it. We for sure know that we're going to have 57 degrees. That's not the issue. What we need to do, though, is we've got to take the decimal and we've got to figure out how many minutes and seconds that will be. So what we're going to do is we've got to figure out, we know there's 60 minutes in a degree, and we know that there's 60 seconds also in a minute. So what we're going to do is we're going to take that decimal and we're going to multiply it by 60, because that will tell us how many minutes we actually have. So we do 0.958 times 60, and that actually gives us a value of 17.748. So we know that we now have 17 minutes. So we have 57 degrees, 17 minutes, but we still have leftover. So now we have 0.748 left over. So now we have to do 0.748, and we're going to do that times 60 again, because there's 60 seconds in a minute. So we do 0.748 times 60, and we get 44.8. Actually, 44.88. So then we're going to write it as 44.88. So notice the little slash marks, that's like an apostrophe, so that means minutes, and then the double apostrophe means seconds. So that means converting this to minutes and seconds is 57 degrees, 17 minutes, and 44.88 seconds. So that part should be pretty easy. All we're doing is finding a fraction or a portion of each 60. So what about when we want to go in reverse? What happens when we want to go from a degrees that's in minutes and seconds into a decimal? This is a little bit different, but pretty much the same. We're going to go to a decimal. So what we're going to do is, we know, again, we're for sure going to have 32 degrees. And then we're going to add 42 minutes out of 60 minutes in a degree. So it's going to be 42 divided by 60. That will give us the first portion of the decimal. The second part, and this is the one tricky part, most people think that it's going to be 27 out of 60 again, but it's really not, because the 27 seconds, if we're converting it to full degrees, we're not doing anything with minutes and seconds anymore, we've got to figure out how many total seconds are there in a degree, not in a minute anymore, in a full degree. So how do we figure that out? Well, there's 60 seconds per minute times 60 minutes per degree, so that ends up being 3,600. So that's what goes on the bottom of the seconds portion, is 3,600. And then what we do is we just add everything up to get one big decimal, and we actually get 32.7075 degrees. And now that is in a decimal. Okay, so I have one that I want you to do on your own. It's one like what we just did. Process does not change whatsoever. So do that on your own, answer the question. Let's see how you do. Hopefully you got 23.41 degrees just by adding up these three numbers. That's pretty straightforward on how that's set up. Okay, moving on to the next thing. Now let's talk about radians and degrees. So the difference between radians and degrees is they're the same. They still are measuring an angle. But what happens is when we talk about the number of degrees that are in a full circle, I assume all of you know this, is 360 degrees. Well, when radians is also used as a form of measure of an angle, and when you get to calculus, everything's going to be done in radians. And the number of radians, or amount of radians that are in a full circle, is 2 pi. And if you think about this, the 2 pi is kind of generated from how we find the circumference of a circle. We take the radius that we have and we multiply by 2 pi to get what the circumference of the entire circle is. So what does that mean? It means that we can actually convert back and forth between the two if we know what a full circle is. So what we're going to do is we're going to learn how to go from degrees to radians, And that's real simple. What you're going to do is you're going to take the degree that you have and you're going to multiply by pi over 180. And the reason why we do that, the reason why the 180 comes into play is because if it's 2 pi for a full circle, then 180 is going to be half a circle, and so is the pi. So we take the degree and we are going to multiply it by pi over 180. So that's our formula. Take the degree, multiply by pi over 180. We will now be in radians. So in reverse, if we want to go from radians to degrees, it's equally as easy. We're going to have radians multiplied by 180 over pi, completely the opposite. And that will put from radians to degrees. Let's get right to it and look at an example. If we want to go from 60 degrees to radians, then we're going to do 60 times pi over 180. And now when you look at this, we end up with 60 pi over 180. And the only thing left to do is to reduce this. So 60 goes into both 60 and 180. So 60 goes into 60 one time. So we don't really need to write the 1, but we still have pi on top. And 60 goes into 180 3 times. So 60 degrees checks out to be pi thirds radians. And again, if you think about that, we have pi thirds. Well, pi thirds is, if you think about 180 degrees. 180 degrees is a half circle. Okay, half a circle for radians would be 1 pi. So 60 degrees is 1/3 of pi. That's where the pi over 3 comes from. So it becomes a lot easier when you start to think of it as chunks of your circle of how much we're going. So pi thirds means 1/3 of the half circle, or or 1/6 of a full circle. But you can use this formula to certainly figure that out. Okay, let's go to the next one. We're going to go from radians to degrees now. We have pi 6. So using our formula, pi 6 times 180 over pi. And if we put this together, we have 180 pi over 6 pi. I'm sure you can figure out the pi's will cancel out. 180 divided by 6 is 30 degrees. And again, the way to think about this is think of it as half circles. Half a circle is going to be 180 degrees. Half a circle is going to be 1 pi. So right here I'm looking at, I'm already in radians, so I already have my pi. 1/6 of 180 degrees is 30 degrees. So that's an easy way to think about it. Think of everything in terms of a half circle. All right, I'm going to have you do this one on your own. This one's a little bit tricky, but what I want you to do is write this one as a decimal. Okay, so do the formula, write out the formula, how you would go from radians to degrees, write out the formula, but then write it all as a decimal. When you divide by pi or multiply by pi, whichever you decide you think you need to do, just write everything as a full decimal. Do not leave pi in your answer. So try that on your own. Let's see how you do. So hopefully you got 1,620.153 or something close to that. You should have rounded to 3 decimal places here. But again, all we did was use the 180 over pi formula because we were going from radians to degrees. So we ended up dividing by pi and got a decimal here. Okay, so moving on to the next thing. This is the last thing we're going to cover. This is really easy if you start to understand this concept. When you see a ray and when you see a coordinate plane, the one thing that we have to begin to understand is when we start dealing with radians and degrees and how we're going to be using this chapter, everything will always start from this point on the axis, which means right here, this ray that goes to the right, that's like saying that this axis right here, that is going to be what we call our initial ray. That will always be our initial ray when dealing with trigonometry and the unit circle, which you'll learn more about. This right here is called your terminal ray. And what we do is we just figure out what the angle measure is between our initial ray and our terminal ray. So in other words, if we start here and I bring the ray up to here, the measurement in radians or degrees right here, that is the distance between, or the measurement between our initial ray and our terminal ray. The initial ray always starts on this axis right here, and then the terminal ray can be anywhere else on our coordinate plane. So when we talk about this example, it says find 2 angles, one positive and one negative, that are coterminal with 45. So again, let's imagine right here that this is 45 degrees. What coterminal means is coterminal means a terminal ray that is in the exact same spot but a different degree. So what I mean by that is We know that this right here is 45 degrees because that's been given to us. What do we mean by another one, a coterminal angle? What we mean is what if we took this all the way around until it got to the exact same spot again? That is actually possible because you know that one revolution is 360 degrees, but that doesn't mean that we can't keep going around. We just keep going. So how do we find a coterminal angle that would be positive? Well, simply put, we're going to just add a full circle to that, which is 360 degrees. We start at 45, and we're adding a full circle of 360 degrees, which gets us 405 degrees. So that's one of them. How do we get one negative? Well, why don't we just go in the opposite direction, which means we're going to subtract 360 degrees. So I'm going to take this angle and I'm going a full circle around in the opposite direction. So now I'm just going to do 45 minus 360, and that gives us negative 315 degrees. There's our two angles that we need. Real simple. But we have to start understanding that an array can be in the exact same spot and have two different angle measures depending on how many times you went around the circle. Okay? So it says find two angles, one positive and negative, that are coterminal with pi fourths. So this is now in radians. Okay? So we're going to do the exact same thing we did before, except now instead of adding 360, we have to add a full circle in radians, which is 2 pi. So now we have to find a common denominator, really easy to do. Fractions, your favorite thing. So 2 pi will convert to 8 pi over 4. Now we have a common denominator, and we have 9 pi over 4. So that's 1, that's the positive one. Now we can do pi over 4 minus 2 pi. So we have pi over 4 minus 8 pi over 4, and we get negative 7 pi over 4. So there's our two coterminal angles there. The big mistake between these two problems, not that they're hard, it's that when you see something in radians, you have to remember that you're adding 2 pi and subtracting 2 pi. You're not in degrees, so therefore you cannot add or subtract 360 degrees to get your answer. So hopefully that's pretty clear. There was quite a bit from this section. So if you have any other questions, I'm sure you'll bring them to class, and I will see you then.